Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of rate of change. This is standard A.3B in the great state of Texas, and we are using item number 50 of the 2023 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a construction worker building steps up to a home, and we have a table here that shows a linear relationship. So that's going to be important for us, because if we know that it's a linear relationship, right, that should be making us think, right, linear equations, right? If we want to write it in standard form, we can write it in slope-intercept form. All of those things are now applying for us, right? So I always think of linear equations. The form that we use probably the most is this slope-intercept form, right? Which means we are looking for a slope. We could calculate a y-intercept if we want to. And so what we're asking here is, what is the rate of change of height off the ground with respect to the number of steps? Okay, so here's my height. Here is my number of steps. So, you know what, if we were to graph this, right, this is a table, we could easily say that, you know, these are our x-coordinates, these are our y-coordinates, right? So what is the rate of change of height off the ground, so that's our y-coordinates, with respect to number of steps? So what does that mean with respect to? Well, that means that we're going to make it like a ratio. So you're almost going to divide it right there, like rate of change y divided by x, or y over x, but it's the rate of change. So the change in y over the change in x. Hopefully you're seeing at this point, that's the slope of a line. Look at that equation at the very bottom there. The slope of a line is the change in y, or y2 minus y1, over change in x, x2 minus x1. So this is just a really long and complicated way for them to ask us, hey, what's the slope? Could you calculate the slope if you were to graph all of these points? Well, of course we can, because all we need to do is grab two sets of coordinates, and it really doesn't matter what they are. So I'm going to start easy, right? I'll start with just these two. What we need to do is we need to make one pair the one pair the two pair. So I'm going to make this x1, y1. I'll make this x2 and y2. You just want to label them, because if you put an x1 with a y2, things won't work out so well. So my y2 is 35, and then my y1 is 21, my x2 is 5, my x1 is 3, so it looks like 14 over 2, which means 7, which we do have that answer there as, you know, C. But does that work with any set I choose? Well, let's do this. Let's choose this one right here. I'll make it a different color. And then let's choose this one right here. But I want to make this one my x1 and y1, and this one my x2 and y2. But you see that a slope of a line is a slope of a line. It doesn't matter which 2 points. It doesn't matter which one you choose as the x1 or the y1. Okay, so my y2 is 49, right? And then that is going to be my y1 of 77. And then I've got my x1 of, or x2 of 11. x2, excuse me, is 7. That's 11. So that's going to be, what, 49 minus 77 is going to be negative 28. 7 minus 11 is negative 4. That's the only difference. If you flip which one, you just get two negatives, which still end up making a positive, right? And then 28 over 4, it's still going to end up positive 7. So it's still the same thing. That is our rate of change. The answer is C.